Welcome back. This is part B of concept video for section 15.6. In the earlier video, I gave you an example where we evaluated a triple integral over a ball, and the limits of x, y, z were all constants. Now we'll do a problem where the limits are all not constants. Evaluate the triple integral, problem number 7. Evaluate the iterated integral 0 to pi, integral 0 to 1, integral 0 to square root of 1 minus z square, z sin x dy dz dx. Try this problem. So step 1, let's write down the integral and call it I. The integral that we want to evaluate is named as I. It's integral 0 to pi, integral 0 to 1, integral 0 to square root of 1 minus z square, z sin x, that is the integrand. Then look at the order, it is dy, dz, then dx. Which means the innermost is dy. That means you have to integrate first with respect to y, and then with respect to z, and then with respect to x. Also, by looking at the limits, we can say the outermost are the limits for x, which are 0 and pi. Then next, the second from the right is z. So z is from 0 to 1. And then y integral is from 0 through a square root of y 1 minus z square. So we recognize that. Now we will integrate one by one. So we'll keep the first two integral as is. Then we will integrate the innermost with respect to y. With respect to y, z and x are constants. So it is z sin x and then y between the limit 0 and square root of 1 minus z square. Then you have to integrate with respect to z and then integrate with respect to x. So I is integral 0 to pi, integral 0 through 1. Then if you plug in the limits here, z sin x square root of 1 minus z square for y, then you have to plug in the lower limit for y, which becomes 0. And this is integrated with respect to z and then with respect to x. As x limits are only constants, limits are definite, we can even remove the sin x and separate it out, and with respect to dx, with respect to x, and then we can integrate this definite limit, which is z times square root of 1 minus t square dz. So this integral sin x is negative cosine x between 0 and pi. For this integral, you can actually use the u substitution. What is u sub? Here u equal to 1 minus z square. So du would be negative 2z dz. You can even change the limits, or you don't have to change the limits. Either way, it's okay. U equal to 1 minus z square. If you're not changing the limits, if you're going to keep u as u, then you have to put the new limits. If you're going to keep z as z in the final, then you can use the original limit 0 and 1. So z is running from 0 through 1. When it is 0, u equal to 1. When it is 1, u equal to 0. So the integral becomes, with respect to u, it becomes 1 to 0. Then it is square root of u, that is for the radical part. Then for this part, z dz is dz is du over negative 2. That is du over negative 2. So I can combine. So for this part, negative cosine x, that is negative cosine pi minus cosine of 0. Then for this part, you can take the minus sign and then you can flip the integral. If you flip the integral, you have to introduce a negative sign. If you flip the limits, then you already have a negative sign. So you have negative and negative makes it positive. It's square root of u du. Outside you have a 2, 1/2. So it is negative 1 minus 1. That is negative 2. Then you have negative of negative 2. That will be a positive 2. That gets cancelled out with 1/2. Then when you integrate, it is u to the power 3 by 2 over 3 by 2 between the limit 0 and 1. So we have negative of negative 2. That is positive 2 1/2. Then you flip the 3 halves. That will be 2/3. Then you have 1 minus 0. So this will be just 2/3. So the value of the triple integral is equal to 2/3. Here we saw how we can apply the varying limits. If the limits are in terms of a variable, like this problem, if you look at this limit, it is involving a variable. So y runs from 0 to square root of 1 minus z squared. So upper limit is a function of z. Then you have to apply the limit, integrate the innermost, and then apply the lower upper limit and the lower limit for the variable y. And then you do the integration with respect to z, then integration with respect to x. You can separate the variables only when they are separable and also the limits are constant limits. So we did that only at this part where we could separate the variable. I will be continuing with this material in part C of the concept video. So check part C of the concept video for section 15.6 for the rest of the material.